Hello everyone, in this lesson we are going to go through the June 2019 paper 3H for the higher tier. We are going to go through every single question, so make sure you write down good notes. Let's get straight into it. So question number one, what do we have? We have a Venn diagram question. We are told that the data set contains the numbers, and in A only, so this is A only, we have all of these numbers, and in B we have all of those numbers. So let's start with this middle part here. This is the section that contains both A and B. So if you have a look at the list of numbers, you'll notice that both A and B have certain numbers in common. So 6 here and 6 here. And we can write that 6 directly in there because they both have it. Another number which is also common is 9. 9 both of them have, so we can write 9 in there. As for the others, A only has 1, 5 and 8. So we can write those numbers in here. Let's use another color. So 1, 5 and 8. So that takes care of all the numbers for A. And B only has the number 2. Now what about all the numbers that we haven't included in A or B? They go outside. So let's use another color for that. And what don't we have? So if we count now, so we've got 1, 2, we are missing a 3. So we can write the 3 in here. And then you go along. So 4 is the next one, so we can write the 4 there. 5, we've got 5, it's in A. 6, we've got 6. 7 we don't have, so 7 can go outside. 8 and 9, and that's all of the numbers. Now the question says, find the probability that the number is in the set A and B. So what is the probability of the number being in A and B? It's these two numbers that we are looking at. So in total, we have 9 numbers, so therefore it will be out of 9, and 2 of those numbers are in A and B. So the probability of A and B is 2 over 9. Okay, question number 2. Katie invests £200,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. Calculate the total amount of interest Katie will get back at the end of 4 years. So let's highlight some key parts. 200,000 is our original amount, it's our principal amount, and we invest for 4 years. And the account pays compound interest at a rate of 1.5% per year. So to calculate the total amount, we'd start off with the original amount, 200,000, and we times it by the multiplier. Now the multiplier, we have 100% plus 1.5% because we are getting an increase of 1.5%. So that gives us 101.5%. So to convert that into a multiplier, we just divide by 100 and we get 1.015. And we do that to the power of 4 because we want to know how much we get at the end of 4 years. And that gives us, you could put this straight into your calculator and make sure you round to 2 decimal places. You get £212,272.71. And that is the amount that you get at the end of 4 years. On to question number 3. This table shows information about the heights of 80 plants. Find the class interval that contains the median. The median is the middle number in a set of numbers. So to find that, we will draw a cumulative frequency column here, or we can add it to the side, and we just add the frequencies as we go along. So we have 7, we add the 13, we get 20, add the 14, we get 34, add the 12, you get 46, and you keep doing this, 62, all the way to 80. And you will notice that this number is always going to be the same as that number. And that's also an indication for you that you've added these up correctly. Now, to find the class interval that contains the median, you could do n plus 1 divided by 2, and n is the total amount that you have. So that is 80 plus 1 over 2, which gives us 40.5. Now, it is the median. Often students make this mistake. They believe that the median is 40.5. It is not. It is the 40.5th value in your list. So where is the 40.5th value? So if you go along here, if you go along the CF column, this contains the first 7 values. This contains the first 20. So the 40.5th value would be inside here. So therefore, it is the 40 and less than 50 class interval. Now, moving on, draw a frequency polygon for the information in the table. Okay, so let's zoom out here a little bit so we can see the table. Now to draw the frequency polygon, we will plot the frequencies on the midpoint of the class intervals. So for the first one, 10 to 20, we look from 10 to 20, we go to the midpoint, which is 15 in the middle, and we go up to 7. Now, you will notice that each of these squares, every two of them is worth 1. And you need to do that before you start plotting your points. You need to work out what each square or every two squares or three squares, what they represent. Okay, so every two square represents 1. So if you go up, you go up to 5, we want to go up to 7, so 6 and 7. 7 will be right there. And we just plot that X there. Moving on to 20 to 30. So 20 to 30, the midpoint is 25. So we go up and we plot on 13. So once again, if you go from 10 and you count up, so 11, 12 and 13 for every two, that will be right there. Next, 30 to 40, so you go up to 14 here, so 1 less than 15 is probably the quickest way to get there. And then 40 to 50, you're plotting at 12, so go up to 10 and then count 1, 2, which is right there. And you have 50 to 60, halfway between that is 55, so go up and go to 16, so 15 and 16 right there. And then 60 to 70, you're plotting at 18, so you go to 20 and maybe count down 2, it's probably quicker, and there you have it. Next, you will get a straight edge, so you're using your ruler here, and you will join these plots. So from there to there, there, there. Make sure you use a ruler to do this. Now, some students leave the polygon like this. If you look back at this table, the minimum we have is 10 and the maximum we have is 70. So it's very important that you actually go down and meet those numbers, and that will create your polygon, as now you have your polygon closing with the x-axis and making a shape. Question number 4. Sean has drawn a time series graph to show the numbers in thousands of visitors to a fun park. Write down 2 things that are wrong or could be misleading with this graph. As you can see, this looks like a car crash of a graph. Hopefully you don't repeat graphs like this. Often, this is something some students may draw for a frequency polygon. So what's wrong with this? Well, the first thing you notice is a time series graph is different to a frequency polygon, by the way. I don't want to get you confused with that. It should be using straight lines as well. So number 1, it should be joined with straight lines, and of course using a ruler too. Number 2 is it doesn't start with the first quarter. As you can see here, you have 2, 3, 4. Now, time series graphs usually show the quarters of a year. In a year, you can break up the year into quarters. You have the first quarter, second quarter, third quarter, fourth quarter. But this only contains 2, 3, and 4. So it doesn't start with the first quarter. So doesn't start with first quarter. Only 2, 3, and 4. Other things that you may want to write is that it doesn't contain 9.5. It doesn't mark that on the y-axis, whereas it's done it for the other numbers. It also doesn't start on 0. It starts from 6 on the y-axis, and many other things. But 2 marks is what the question is offering, and those 2 are sufficient. All right, so question number 5. This diagram shows a hexagon. A hexagon, as you know, has 6 sides, so you might want to make a note of that. So 6 sides, and it has 1 line of symmetry, and we could draw that in actually. So let's do that. It's not very straight, but it will do. Okay, so if it's got 1 line of symmetry, we can add some more information to our diagram. So this angle here would be the same as 117 on the other side. And now we can go and read what the information says. So it tells us that F to A is equal to B to C, and you can see that by the markings, and also E to F is equal to C to D. Then it tells us that, it also tells us what we've just discovered, which is that the angle ABC is equal to 117. Then it tells us this very, very important part right there. It tells us that the angle BCD, so that's this angle right there, is equivalent to 2 lots of CDE, this angle right there. What does that mean? It means that if I write an X for this one, this is going to be worth 2 of those. Okay? And we can repeat that on the other side. So this will also be 2x, and this will be x. Now you can see that we have all of the angles in the hexagon covered. We just need to know what the angles in the hexagon add up to, so that we can work out the angle of AFE, as the question says. For this, you need to know the sum of the interior angles of a polygon. Okay, so I'll write that down for you. Sum of interior angles of a polygon. And the formula for that is n minus 2, n meaning the number of sides, and you times that by 180. So for our question, we have a 6-sided polygon, so it will be 6 minus 2 times by 180. If you put that into your calculator, you get 720 degrees. So all of these angles add up to 720 degrees. Now all we will do is add, let's do this in another color, we'll add all of the angles and make it equal to 720, thus forming an equation. So we have 117 plus 117 plus 2x plus x plus x plus 2x, and that equals to 720. If we collect all the like terms, so we add up all the numbers and collect all the x's, we get 234. Add all the x's, you get 6x, and that equals 720. Take the 234 to the other side, so you get 6x is equal to 486, and then finally divide by 6 on both sides, and you get 81 degrees. So x is equal to 81 degrees, so angle AFE, which is equal to 2x, therefore 2 times 81, which gives us 162. So angle AFE right there is equal to 162. Right, on to question number 6. Jeremy has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 and a height of 1.8 meters. Jeremy has 7 tins of paint. Each tin of paint covers 5 meters squared. Has Jeremy got enough paint to cover completely the 3 tanks? You must show how you get your answer. Now this question may seem very wordy, but we will break it down. So let's start right at the top. It says he has to cover 3 tanks with paint. Now this means that we are going to be looking at the surface area. So let's make a note of that. Then it tells us that the tank has a diameter of 1.6. Very important. So if the diameter is 1.6, the radius is going to be half of that, 0.8. Let's make a note of that too. So radius is equal to 0.8 meters. And it has a height of 1.8. Let's start off by finding the surface area of this cylinder. So let's write that down. We are going to find the surface area of the cylinder. The formula for this, you may know it, but you can also work it out. You have 2 circles and you have this part in the middle, the curved surface area. So you have 2 circles, the top and the bottom. So you can write down for that 2 lots of pi r squared, because pi r squared gives you the area of a circle. And then you add this to the curved part. Now I'm going to do something here. Imagine you open up this cylinder, okay? This is what it will look like. It will look like a rectangle. Now the height of this rectangle, 1.8, will be represented right there. So let's write that down, 1.8 meters. What about this length of the rectangle? Well, this length of the rectangle would be represented by the circumference of a circle. So what is the circumference of a circle? We know that the circumference of a circle is pi times diameter. So we can write that down right now because we know the diameter. So it's going to be 1.6 times pi. And you can leave it like that if you want. So now we can add the area of this rectangle to our formula. So to find the area of this rectangle, we do 1.6 pi times by 1.8. So let's write that down here. So 1.6 pi times by 1.8. Let's get our calculators and do these calculations, and we also need to put in the value of the radius for the circle. So we have 2 times pi times 0.8 squared plus the answer to this, which we'll do in the next line, all of these decimal values. So if you do 2 times pi times 0.8 squared, on your calculators you should get 4.021238597. Now you'll notice I'm keeping all these digits because I will round as late as possible so that I don't get any rounding errors. I don't truncate the numbers and then go way off with some of the final answers. Okay, and 1.6 pi times by 1.8, we get 9.0477868843. Let's add those numbers up and we get 13.069025544 meters squared. So this is the surface area of the entire cylinder, including the top and the bottom. Now we can round this, it might be easier as we move on. So let's round it to 3 decimal places. So you get 0.69 meters squared to 3 decimal places. What's next? We've worked out the surface area of this cylinder. We know that Jeremy has 7 tins of paint. So let's work out how much paint he has. So the paint, 7 tins times by 5 meters squared each tin. So he can cover with his 7 tins an area of 35 meters squared. He needs to cover 3 of these cylinder tanks. So 3 of 13.069. So therefore 3 tanks is 3 times 13.069, and that gives us 39.207 meters squared. This is what he needs to cover. As you can see, he does not have enough paint, so therefore he's short of paint by, you can work out the difference, which is 4.207 meters squared. So the answer is no, he does not have enough paint. Right, question number 7, hopefully you're still with me. This one is worth 2 marks. You can do this straight into your calculator, but if you make a mistake, you are not going to get any of the 2 marks. So it's really, really important that you do show your working out. All right, so we're going to work out the top separately and the bottom separately. That square root is square root in the numerator and the denominator, so we can do that separately here. So let's work out 2.5 times by sine 43 on our calculators, and we get 1.7049959. And now the denominator, 8.2 squared minus 50.5, and we'll put that in its own square root sign. You get 16.74. Now let's square root the top and the bottom. The top gives us 1.305754916, and the bottom gives us 4.0914545509. Finally, let's put this into our calculator and divide, and you get 0.319141986. Now the question says give your answer to 3 significant figures, so you must round this answer to 3 SF. So you get 0.319, and that's 3 SF. Question number 8. ABC is a right angle triangle. Here is Sarah's method to find the length BC. As you can see, Sarah has made a mistake. The question tells us this, and it tells us to find what the mistake is in her method. Now, if you look at this method, she's used Pythagoras' theorem, and she's used BC squared, which is the length right here, so BC. Now we know that BC is not the hypotenuse. The hypotenuse is opposite the right angle, which is the side A to C. So what she should have done is 8 squared minus 6 squared. So 8 squared minus 6 squared, and then square rooted that answer. Given her, or it would have given her, root of 28 and consequently BC would have been 5.3 if centimeters rounded to one decimal place. So that's the mistake that she made by adding the two values. Part B of question number 8, Roy is going to enlarge triangle PQR with the center C and a scale factor of 1.5. He draws triangle XYZ. Explain why Roy's diagram is not correct. Now, as you can see, he's done the center of enlargement okay. As you can see, it goes through every single vertex quite nicely, and that's all good. But where does the problem lie? Well, the problem lies if you look at the scale factor. If you compare this length and this length, they should have the scale factor of 1.5 or 1.5. But you will find that they don't. If you count along here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 and this is 1, 2, 3, 4. So if you do 10 divided by 4 to find your scale factor, you will find that this gives 2.5, not 1.5, which is what the scale factor is supposed to be. So that is the mistake that Roy has made, and his diagram is therefore not correct because he has used the wrong scale factor. Right, on to question number 9. Now this is a very interesting question. A company has to make a large number of boxes. The company has 6 machines. All the machines work at the same rate. When all the machines are working, they can make all the boxes in 9 days. The table gives the number of machines working each day. Work out the total number of days taken to make all the boxes. Now the topic for this is proportion, direct proportion. So let's begin. Let's highlight some of the key bits of information. Now the company has 6 machines, but all of them don't work at the same time. As you can see, on day 1, we had 3 machines working. On day 2, we had 4, and day 3, we had 5 machines. But all the days after that, day 4 and 5 and so on and so forth, all 6 machines were working. Now the question says when all the machines are working, they can make all the boxes in 9 days. Now in an ideal situation where all machines are working, you have 6 machines going full out for 9 days, and that would be a total of 6 times 9, which is 54 days. Now, this 54 days is 54 machine days. This is 54 days of the machine at work. Okay, all 6 machines, and all the boxes are complete. So we need to make up 54 machine days. That's our target. So let's have a look at our table and see what actually happens. If you look at the table, you see that days 1, 2, and 3, there were only a total of 12 machines working throughout those days. If you add up 3, 4, and 5, that's what you get. You have 12 machines working. Now, if 12 machines are working, this is equivalent to 2 days of 6 machines working. Okay, so let's write that down. So 2 days of 6 machines full on at work is equivalent to 12 machine days. So what we can do is we can take away these 12 days from our machine days. So we can do 54, take away 12, and that leaves us with 42 machine days required. So we need to make up the 42 machine days left after day 3. So we can do 42 divided by 6. Now why 6? Because every day after those first 3 days, all 6 machines are working. And this tells us 42 divided by 6, that 7 days are needed to do the rest of the work. And all we'll do now is add the 7 days to the first 3 days, so 7 plus 3, and that tells us that we can get everything done in 10 days. So the fact that on days 1, 2, and 3, all the machines were not working, it added an extra day to our work. Otherwise, everything could have been done in 9 days. Okay, question number 10. Mary invests £8,000 in an account for 1 year. At the end of the year, interest is added to her account. Mary pays tax on this interest at a rate of 20%, and the tax that she pays is worth £28.80. Now, let's start off with the formula that we used earlier on, which was original amount, 8,000, times by the multiplier. But we don't know what the multiplier is. Okay, so we'll write an X here. And this is equal to the new amount, which we also don't know. So this is the new amount after 1 year. What do we know? We know that 20% of the tax that she paid is worth £28.80. So we need to know what amount she paid a tax on. We can do that by going down to 1% by dividing both sides by 20. So £28.80 divided by 20 gives us £1.44. And then we can go back up to 100% by timesing by 100. So we multiply this side by 100 as well. So £1.44 times by 100 is equal to 144. So this is the amount that she paid an interest of 20% on. So if we now add this amount of £144 at the end of the year to her £8,000, we get the new amount. So therefore 8,000 times by X is equal to £8,144. Now we can work out the multiplier because the question says work out the percentage interest rate for the account. So we can do 8144 divided by the original amount 8,000, and that would give us X is equal to 1.018. So the percentage interest rate for the account is this amount right there, and that is 1.8%, because everything after the decimal place in 1.018 represents the increase. Moving on to question number 11, May 2019, the distance between Earth and Mars was 3.9 times by 10 to the power of 7. In May 2019, a signal was sent from Earth to Mars. Assuming that the signal sent from Earth to Mars traveled at a speed of 3 times 10 to the power of 5 kilometers per second, how long did the signal take to get to Mars? Now, as I was reading this question, and I'm sure as you were reading the question, we're talking distances, we're talking speed, and we're talking time. So DST must have come into our heads. I hope it did. So DST. So we are looking for time, how long. So we are going to rearrange this by covering up T, and we get time is equal to distance divided by speed. And our distance is 3.9 times by 10 to the power of 7, and our speed is 3 times 10 to the power of 5. We can just knock this straight into our calculator and we get 130 seconds. So the answer is 130 seconds it took. Now if the question does say to put this into standard form as well, although it doesn't, it would be 1.3 times 10 to the power of 2 seconds. The question goes on to say that the speed of the signal sent from Earth to Mars in May 2019 was actually less than 3 times 10 to the power of 5 kilometers per second. So how will this affect your answer to part A? Well, if the speed is slower, it will take longer. So it will increase time taken. Question 12, Patrick has to work out the exact value of 64 to the power of 1 over 4. Patrick says 1/4 of 64 is 16, so 64 to the power of 1 over 4 is 16. Explain what is wrong with what Patrick says. As you know, when you have indices as fractions, you need to take the roots. So 64 to the power of 1 over 4 would mean to take the fourth root of 64. The fourth root of 64 is 2.828 ... So Patrick, rather than taking the fourth root, has taken 1/4 of 64. Okay, question number 13 now. The density of ethanol is 1.09 grams per centimeter cubed. The density of propylene is 0.97 grams per centimeter cubed. 60 liters of ethanol are mixed with 128 liters of propylene to make 188 liters of antifreeze. Work out the density of the antifreeze. Give your answer correct to 2 decimal places. Now, for this, we need the formula MdV. Mass is equal to density times volume. So let's write that down. Mass is equal to density times volume. And we can rearrange this formula to find volume or density as well. Right, so let's begin. So what do we have for ethanol? We know that the density is 1.09 grams per centimeter cubed. And the volume that we add of ethanol is 60 liters. Now we need to have a conversion because we've got grams and centimeter cubed, and we're also dealing with liters. So therefore 1 liter is equal to 1000 centimeter cubed. So let's make a little note of that right there. Okay, now for ethanol, to calculate the mass, we use density times volume. So it would be 1.09 times by the volume. Now our volume is in liters. We need to convert that into centimeter cubed by multiplying by 1000. So 60 times by 1000 is 60,000 centimeter cubed. And that's the value we'll use in our formula. So 60,000 right there. And put this into your calculator, you get the mass, which is 65,400 grams. So the mass of ethanol is 65,400 grams. For propylene, we know that the density is 0.97 grams per centimeter cubed, and we are told that the volume added to the antifreeze is 128 liters. Once again, let's convert the 128 liters into centimeter cubed by multiplying by 1000, and we get 128,000 centimeter cubed. So now to find the mass, we will do 0.97 times by 128,000, and that gives us 124,160 grams. So this is the mass of ethanol. So the total mass of the antifreeze, that would be adding up the mass of ethanol and propylene. So that's 65,400 plus 124,160, which gives us 189,560 grams. That's the mass of our antifreeze. The question says work out the density of the antifreeze. So we will rearrange this formula. So density is equal to mass divided by volume. So density is equal to mass divided by volume. So the mass is 189,560, and the volume, which we were given, is 188 liters. Once again, you need to make 188 liters into centimeter cubed. So by multiplying by 1000, so it'll be 188,000 centimeter cubed. So let's just put the units in there. And we work that out on our calculators, and we get 1.008 ... grams centimeter cubed. Question does say to round to 2 decimal places. So if we go back here, we get 1.01 gram centimeter cubed. And that is our final answer. Right, question number 14. This diagram shows a rectangle ABDE and 2 congruent triangles. Now the word congruent, it means exactly the same. The area of rectangle ABDE is equal to the area of the triangle AFE and the triangle BCD. So what does this mean? It means the area of this is equal to this plus that. Let's set up our equation. It also tells us that the ratio of AB to AE is 1 to 3. So let's also make a note of this. So if A to B is X, let's call it X, so X right there. Therefore, A to E is going to be worth 3 times that, so 3x. So A to E, we can write 3x. We can say this is also x and this is 3x. All right, question says to work out A to E. So let's make a note of A to E. We want to work out the length right there, which is basically working out what 3x is. How can we do that? Well, we can go back to this piece of information right there, where the area of the rectangle is equal to the area of both the triangles. So let's find the area of the triangle. So this is 30, this is 3x, and this is 24 centimeters. Now to find this area, it's a non-right angle triangle. So we can't use base times height divided by 2. What we have to use to find the area of this triangle is half AB sine C, which is the sine area rule. So a half times by A. Now, if we label this triangle, so this is the angle, so this is very important to label as C, and therefore this will be side C. And A and B can be any of these vertices, so therefore 3x can be our A, and 24 will be our B. So therefore our A here is 3x times by 24 times by sine 30. And if you put this into your calculator, bar the x, everything else you should be able to calculate. And you should get 18x. So the area of the triangle is 18x. Two of those triangles would be equal. So 2 times 18x would be 36x. And we know that 2 of the triangles is equal to 1 rectangle. And the rectangle here was x and 3x. So the area of the 2 triangles was 36x, and to work out the area of this rectangle you do x times by 3x, which is 3x squared. So now we have an equation and we can just solve this. So what we can do is take the 36x to the other side. Now often some students might choose to divide by x here. In this particular instant it may not make a difference to your final answer, but it's very important that you understand, in order to factorize and find all the solutions in a quadratic like this, you take 36x to the other side and you factorize it. So you get 3x squared minus 36x equal to 0, and then you take out the x and the 3 as well. So you have x minus 12 equal to 0, and this has to equal 0, or this has to equal 0. When the 3x is equal to 0, x cannot be equal to 0 because x is a length here, and we can't have a 0 length, a length that don't exist. So therefore x will equal 12. So if x is equal to 12, that will be the length of A to B, but we want to work out A to E, which was worth 3x. So A to E is equal to, let's write this here, A to E is equal to 3x. So 3 times by 12, and that gives me 36 centimeters. So A to E is 36 centimeters. All right, so question number 15, we're almost right to the end. The graph of the curve C with equation y equals f of x is transformed to give the graph of the curve S with the equation f minus x minus 3. The point on C with coordinates 7, 2 is mapped to the point Q on S. Find the coordinates of Q. Now, let's write down this transformation right there and work out what happens. When you have a minus here, you have a reflection in the y-axis. Or you can think of it as a change of sign in x. So if your x is a positive coordinate, you can put a minus sign there and make it a negative. Change in sign in the x coordinate. Now, what happens to the minus 3? Well, the minus 3 would mean that the y coordinate moves down by 3. If it was a plus, it will move up by 3. So now let's compare our coordinate 7, 2. So what did we say happens? We said that a minus in the x would change the sign in the x coordinate. So instead of 7 now, this would become a minus 7. And we also said that the minus 3 here would mean that the y coordinate, which is this, would move down by 3. So 2 minus 3, which gives us minus 1. So this is the coordinate of Q. Right, moving on. Question 16. Here are the first 6 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Let's start by finding the differences. So the difference between this number here, this number there, there, and there. Now you can see that the difference between each one is plus 6 here, plus 10, plus 14, plus 18, and plus 22. Now the differences are not constant, so we need to continue by finding the difference of the difference. So let's do that. So we have plus 4, plus 4, plus 4, plus 4. Now quadratic, the second difference will always be the same, and what you do is you half it. So the half of 4 is 2, and you put it with an n squared, and you just put that to the side. Next, you draw out the table, and if you need help on this, please do see the video I have on quadratic and finding the nth term of a quadratic sequence. So you have the term numbers here. So these are just simply term number 1, term number 2, 3, 4, 5, and 6. There are 6 terms here. And you have the original. And the original is -1, 5, 15, 29, 47, and 69. And in here, you write your 2n squared, which you found by taking the term numbers, squaring it, and multiplying by 2. So if you take the first one, 1 squared, which is 1, times by 2 is 2. 2 squared is 4, times by 2 is 8. 3 squared, so what I'm doing here in case you're trying to follow is I'm taking this value and putting it in here as our n. So 3 squared is 9, times by 2 is 18, 4 squared is 16, times by 2 is 32, 5 squared is 25, times by 2 is 50, 6 squared is 36, times by 2 is 72. Now, we will find the difference between the original and our 2n squared. So -1 minus 2, we get -3. 5 minus 8 is also -3. 15 minus 18 is -3. 29 minus 32 is also -3. And you'll notice that all of them are -3. Next, although we know what it is, we do try to find the difference of this new sequence, which will always be a linear sequence if you've done everything correctly. Now the difference is 0, 0, 0, 0, 0. So going backwards, we also go backwards by 0. I know it sounds quite silly or looks quite silly doing this. So we still get -3. But the reason I did this is to teach you, and when you look at that video, you'll know, is to teach you how to find the quadratic sequence for any sequence of a quadratic. All right, so we have 0n minus 3, and we'll add this to our 2n squared. So we have 2n squared plus 0n, which we'll get rid of, and -3, which will give us 2n squared minus 3. And this is our answer. This is our expression in terms of n for the nth term of this sequence. And you can test this. So for example, if you want to test it by finding the third term, so we want to find 15 by subbing in 3. So 3 squared is 9, times by 2 is 18, minus 3 gives us 15. And you could do that for the fourth term. So 4 squared is 16, times by 2 is 32, minus 3 is 29. So our sequence works. Question number 17. Here are 4 graphs. The graph represents 4 different types of function f. And we have to match the description of the function in the table to the letter of its graph. All right, so let's have a look at the graphs and the descriptions. I'm going to zoom out a little bit here so you can see what's down there. All right, so we want to find a graph which is inverse proportion. Now, inverse proportion is this graph right there. So that's B. Next, we want to find a trigonometrical function. So this looks like graph A right there. Exponential function, that's just sticking out like a sore thumb right there. So D. And direct proportion to the root of x. Now, I mean, obviously it is graph C, but just a bit of further information on that. You can only do a square root of a positive number here. So you'll notice that this only contains the positive and there's nothing on this side right there. So that is an extra piece of information just going forward. Okay, so we have B, A, D, and C. Right, question 18. Show that 2x plus 1, x plus 3, and 3x plus 7 can be written in that format, where A, B, C, and D are integers. This basically is to expand triple brackets. I also have a video on expanding brackets. Do check that out if you need further help. Now you can do this in any order if you like, okay? I'm going to choose to expand these two first, and then I'm going to get the result and then expand with the 3x plus 7. So let's go. 2x plus 1 and x plus 3. So I'm going to expand that out. I get that times that very quickly. So 2x squared plus 6x plus x plus 3. Collect the like terms. So 2x squared plus 7x plus 3. Now I will introduce my 3x plus 7 bracket, which is here, right there. And I will expand everything out once again. So this times by that, then this times by that, then this times by that, and this times by that, and this times by that, and that times that. So let's do this. 2x squared times by 3x is 6x cubed plus 14x squared plus 21x squared. Right, so I've expanded everything out now. I will collect the like terms once again. So we have these like terms and we have these like terms. So 6x cubed plus 14 plus 21 is 35x squared. 49x plus 9x is 58x, and we have the 21. So that's my final answer. So on to part B. Solve this inequality. You'll notice that you have a square on the left hand side and you have square numbers on the right hand side. So we can take the square root of both sides, leaving us with 1 minus x is less than plus or minus 3 over 5. The plus and minus, every time you square root a number, you get that plus and minus. So we have two sets of solutions. We have 1 minus x is less than plus 3 over 5, or we have 1 minus x is less than minus 3 over 5. So if we take the plus version first, what we can do is we can leave the 1 on this side, and when we take the plus 3 over 5 to the other side, so we are treating this like an equal sign, really, okay? And when we take the 3 over 5 to the other side, we will get a negative. And we can take the minus x to the other side and get a positive. So we end up with that, which gives us x is equal to 2 over 5. That's one of our critical values. Now the other version, I did say to you, what we can have is 1 and minus x is less than minus 3 over 5. Once again, we'll take a minus 3 over 5 to the other side. So therefore 1 plus 3 over 5, because the sign changes, and we can take the minus x to the other side, so we get equal to x. I'm only using the equal sign here just for my working out. I know it's a less than sign, it's just to get my critical values. So what does 1 plus 3 over 5 give me? That gives me x is equal to 8 over 5. Now these are my critical values. What we'll now do to work out my range of values, I will draw my critical values, so 2 over 5 here, and let's just draw 8 over 5 there. And I will now draw my quadratic. Now, just to see how my graph will look, I will now kind of solve this by multiplying the 25 to the other side. So 25 times by 1 minus x squared less than 9. And then I will expand this bracket, so I get 25, and in the bracket I'll get 1 minus 2x plus x squared is less than 9. I can now expand this bracket out if I want to, but I don't really need to, because what was important is right there. I have a quadratic which is positive because of the positive sign right there. So I can go back down here and I can draw my quadratic. Now another reason why I did this expansion here is to work out whether I'm going below the axis or above the axis, the x-axis here. If I get rid of this 9 by dividing by 9, I will end up with a 0. So everything on this side will be less than 0. So less than 0 are my y values. So therefore I am looking for everything less than 0. I am looking for all the values between there. So my range of answers for x will be less than 8 over 5, but greater than 2 over 5. All right, question 19. We're almost there, guys. So we have this formula. U is equal to 26.2, correct to 3SF, and A is 4.3, correct to 2SF. Calculate the upper bound for the value of D. So what we can do is find the upper and lower bounds of both of these values. So for U, we have 26.2 is less than and greater than or equal to. Now it's rounded to 3 significant figures, so the upper bound would be 26.25 and the lower bound would be 26.15. If you need more help on this, I do have a video on my channel, so do go and search upper and lower bounds. As for 4.3, we have the upper bound as 4.35 and the lower bound as 4.25. So to calculate the upper bound for D, so D upper, we need the maximum U squared over 2 times the minimum A. Right, so the maximum u squared would be 26.25 squared over 2 times the minimum a, which is 4.25. Put this into our calculator, we get 81.06617,647. And we've been told to round it to 6 significant figures, which would be 81.0662. That's 6 SF. Now, the question says the lower bound for the value of d is 78.6003, correct to 6 SF. By considering bounds, write down the value of d to a suitable degree of accuracy and give a reason for your answer. When a question says by considering the bounds, it means to consider the lower bound and the upper bound. Now, the lower bound is given to us as 78.6003 and the upper bound, which we worked out, is 81.0662. If we look at both of these, we can see that if we try to round to 1 decimal place, they don't match. 2 decimal place, they don't match. However, if we were to round to SF, right there and there, they both round to the same value. 78 rounds to 80 and 81 rounds to 80. Question number 20, solve algebraically the simultaneous equations. Now you have a quadratic and you have a linear. So let's start by labeling 1 and 2. I have a video for this on the channel, so if you need further help on this, go and check that out, guys. So we take equation number 2, the linear, and we rearrange in terms of the x or the y. So if we rearrange this, so rearrange, we get, I'm going to rearrange in terms of x. So I'm going to take the 4y to the other side and then divide by 3. So I have x is equal to 7 minus 4y over 3. And that is what I would sub into equation number 1. So let's go. So equation number 1 is x squared, and my value of x is 7 minus 4y over 3. So 7 minus 4y over 3 all squared. Then it says minus 4y squared is equal to 9. And I will now just expand and solve this. Now this might look a little bit tricky, this bracket, but what you can do is do 7 minus 4y in its own square, and you could also do 3 squared. That will now be easier to work with, and let's just write this down as well. So 7 minus 4y, we'll expand this out, the double bracket. That gives us 49 minus 56y plus 16y squared, and 3 squared is 9. And then we have the minus 4y squared right there. Now, to solve this, we will multiply by 9, so we'll multiply that by 9, and that will get rid of the 9 over here, so we get 49 minus 56y plus. Now, the 9 also multiplies with the minus 4y squared, giving us minus 36y squared, and of course it multiplies with the 9 on the other side of the equation, so you get 81. Next, we'll collect all the like terms and put everything over to one side, so we have only 0. So that gives us 20y squared plus 56y plus 32 equals to 0. What we can do to make this more simple, we can divide by 2 again. So in effect, we can divide the whole thing by 4, and we get 5y squared plus 14y plus 8 equals 0. And now we will factorize this. So double bracket here, we get 5y, to make 8. We get 2, and we can have a 4 there. Again, if you need help on factorizing quadratics like this, go and check out the video on the channel. Right, so from here, from this bracket, we get y is equal to minus 4 over 5. And from this bracket, we get y is equal to minus 2. So those are the two values of y that we can have. Subsequently now, all we need to do is find the value of x. So if we go back up here, we can use this to find the value of x by subbing in the y values here directly. So let's do it down here. So if we have this, therefore x is equal to 7 minus 4 times y. Now our y is minus 4 over 5, and then we divide that by 3. So x will be equal to, you can just put this into your calculator, you get 17 over 5. As for the other one, if you sub in y equals minus 2 into the equation, so you get x minus 4 times minus 2 all over 3, you get x is equal to 5. So our two coordinates are 17 over 5 minus 4 over 5 and 5 and minus 2. So these are the solutions to our simultaneous equations. Right, question 21, histogram gives information about the distribution of the weights of some onions grown by a farmer. Onions less than 60 grams in weight are used for pickling. Onions greater than 120 grams in weight are sold at the market. The rest of the onions are sent to a food processing factory. Now, it appears that there is no question to this. However, if you read on, it says a pie chart is drawn using the information opposite. Well, it's not really opposite, it's above there, but it would be if it was on the paper, of course, in your exam. A pie chart is drawn using the information opposite to show what the farmer does with the onions he grows. The angle of the sector for the onions sent to the food processing plant is X. Work out the value of X. Right, so it does want us to use this histogram, and how? Well, we need to know what the onions less than 60 grams in weight are, how many there are, how many onions greater than 120 grams in weight sold at the market, and we need to know how many are sent to the food processing factory, because this is what it wants us to do. Find how many are sent to the food processing factory, but of course calculate the angle itself in the end. But before we can calculate the angle, we need to know how many have been sent. And this is why we will use the histogram. Now, what things do we know about histograms? So let's prepare a table for our histogram. So we can do this table here. We have the class widths, and we have the frequency density, and we have frequency. Okay, so the class width we have from 0 to 60 for the first one. So we can write down here 0 to 60. Then we have 60 to 90. We have 90 to 120. We have 120 to this thing in the middle. So the middle of this, how do we work that out? Now, you will notice that right here is 150. So it's halfway exactly between that. So half of that, this is 30. So half of that will be 15. So you just add 15 to 120. And that gives us 135. So the next one will be 120 to 135. Now continuing on from this, let's get rid of this. Continuing on from this, we get 135 all the way to 180. So let's zoom back out here. Now what we will do is work out the frequency density of each one. So between 0 to 60, the frequency density here is 2. So we can write that here. Between 60 and 90, the frequency density is right there, which is 5. So we can add 5 right there. 90 to 120, the frequency density is 9. And from 120 to 135, it is 6. From 135 to 180, it is 2. Now, the formula to calculate frequency is frequency density times by the class width. This formula comes from the formula that you are taught when you do frequency density, which is frequency divided by class width. I've just simply rearranged this. So the class width for the first one is 60. So it will be 60 times by 2, which gives us 120. Next one, the class width is 30. So it will be 30 times by 5, which is 150. The next one, the class width is also 30. So 30 times by 9, which gives us 270. The next class width is 15. So 15 times by 6 is 90. And the class width after that is 45. So 45 times by 2 is also 90. We'll now add up the total frequency. So 120, 150, 270, 90 plus 90, and that should give us 720. So we have 720 onions represented in this histogram. And we are told that onions that are less than 60 grams in weight are used for pickling. We are told that the onions greater than 120 grams in weight are sold at the market, and the rest of them are sent to the food processing factory. So how many onions are less than 60 grams in weight? Let's look at our table. This is why we drew our table. So we can see on our table that between 0 to 60 grams in weight is 120 onions. So 120 onions are sent for pickling. Onions that are greater than 120 grams are sold at the market. So 120 grams and above are all of those. So that's 90 plus 90. So therefore, that gives us 180 onions that are sold at the market. What's the leftover? So if you add 120 and 180, you get 300 onions. So the leftover is going to be from 720. So 720 minus 300, it gives us 420 onions. And these are the rests, okay, which are sent to the food processing factory. Let's now go and complete our information on our pie chart. So now we know that this X here is represented by 420 onions out of our 720 onions. So we can do 420 divided by 720. And how do we turn something into an angle for a pie chart? We multiply it by 360 degrees. And this gives us 210 degrees. So the value of X is 210 degrees. On to question number 22. We have a circle and we have a tangent to the circle which meets the x-axis at 30 degrees. We are told that P coordinate is 3P, P, and the B coordinate is 16, 0. And the information is also told to us here in the text. Find the value of P, giving your answer to one decimal place. Where do we begin? Well, first things first, let's write down the equation of a circle. The equation of a circle is x minus a squared plus y minus b squared is equal to the radius squared. The a and the b represent the center, and the center of the circle is at the origin, which is 0, 0. So we can just have x minus 0 squared plus y minus 0 squared is equal to r squared, which we don't know. And this simplifies to x squared plus y squared is equal to r squared. So this is the equation of the circle. We can find more information by looking further at our tangent. Now we know that the tangent meets the radius of a circle at 90 degrees. And if we were to draw that, because we need to know the radius eventually, so if we were to draw that now, we have a radius meeting the tangent at 90 degrees. But we also have a triangle. So let's draw this triangle separately. So this would be our A, this would be our O, and this would represent the radius. This is 30 degrees, and this is point B, which we know is 16, 0. Let's write this in as well. So therefore, the distance from O to B is 16, because it's 16 along the x-axis. So O to B is 16 right there. This is enough information to start our process. So if we label this as hypotenuse, adjacent, and opposite, we want to find R. So we need to use opposite, and we've been given the hypotenuse, so therefore we will be using sine. So sine 30 is equal to opposite, which is R, over the hypotenuse, which is 16. If we rearrange that, you get R is equal to 16 sine 30. So if you calculate that, that gives you 8. So the radius is 8. So we can go back to our equation and we can write down the radius squared. So therefore 8 squared would be 64. Now, we are told that P is a point on the circle. It lies on the circle. So we can use that information by substituting the 3P as X and P as Y into the formula of our equation of a circle. So we are going to sub 3P P into the equation. So therefore for X squared, we get 3P squared. And then for Y squared, we get P squared. That's equal to 64. If we expand this out now, we get 9P squared plus P squared is equal to 64. 9P squared plus P squared is 10P squared is equal to 64. And P squared would be 64 divided by 10, which is 6.4. And therefore, square rooting both sides would give us P as equal to 2.5. It can also be plus and minus 2.5, as I said earlier on. But in this case, we know that our value of P here is a positive because it's in the positive quadrant. So therefore, P is equal to just 2.5 positive. So the final answer, P is equal to 2.5 to 1 decimal place. All right, question number 23. The diagram shows the position of 3 towns. Question wants you to find the bearing of Chorlton from Acton. So the bearing of Chorlton from Acton. So if we were to draw a line between town A, Acton, to Chorlton, right there, the bearing we are looking for is this right there. That's the angle we want to calculate. In order to calculate this angle, we need to know what this angle right there is. And we will now take that diagram, that triangle, and draw it out separately here. So we can have A, C, and B right there. And we want to work out this angle X. We know that this is 8 kilometers. We know that this is 9 kilometers. Now, since this is a non-right angle triangle, we can use our cosine rule or our sine rule to work this out. Sine rule is easier to work with, but for the sine rule to work, you need to have opposite pairs. So this is good because we're going to be using this. It's okay that we don't know the angle A. However, unfortunately, we don't have another pair of a side and an angle. So we can't apply the sine rule just yet. So what we can do is look back at the original diagram and calculate other things. Now you will see 2 parallel lines right there because they are the north directions. When you have 2 parallel lines like this, therefore these angles here are co-interior angles, which means they add up to 180. So to find what this angle right here is, you will do 180 minus the 37, and that gives you 143 degrees. Well, if that's 143 degrees, I can also know what this angle right here is, because angles on a point add up to 360. So I can do 150 plus 143, and I can take that away from 360, giving me 67 degrees. So this angle right here is 67. I can go back into my diagram and add this right there. Now that I have the angle B, I can find the side A to C by using the cosine rule. Just to make things easy for all types of learners, I will show you a little trick. I'm going to be doing away with the original labeling, and I'm going to label it A here and small a here, B and C. There's a reason for this, because I want you to be able to apply the cosine rule no matter which set you are in. So if you're in the middle sets, some students, they don't like rearranging or changing the letters from the original formulas. So the cosine rule, as you know, is a squared is equal to b squared plus c squared minus 2bc cos a. So our values now will fall right into the formula. So a squared is a squared. So we have b squared. So let's label this b and this c. So b squared will be 9 squared plus 8 squared for c minus 2 times b, which is 9 times 8 times cos a, which is 67. Now, very, very important, guys. Do these calculations separately. Don't try to be a hero and put all of this into your calculator. Often, very frequently, students make mistakes and they get the wrong answer, although they were so close. So work out 9 squared, add to 8 squared, and that gives you 145. Work out what 2 times 9 times 8 is, which is 144, times by cos 67. Now you can put this all into your calculator and then square root the answer, and you should get 9.4199 dot dot dot. Let's round this, so 9.42 to 2 decimal places. So now we know A right there is 9.42. Let's go back to our diagram. 9.42 kilometers. We might as well add it in there as well. Now that we know what A is, we can use our sine rule to find this important angle, which represents that, remember. Okay, so let's apply our sine rule now. So sine x over 9 is equal to, we are going to use this pairing right there. So that's equal to sine 67 over 9.42, because we found A earlier on, which is 9.42. I should write it down here as well, just in case you wonder. Right, we are going to rearrange this now. So we make sine x the subject. So you get 9 sine 67 over 9.42. And because we are finding an angle, we'll do the inverse of sine. So 9 times sine 67 over 9.42. And that gives us 61.577 dot dot dot, and we can round this to one decimal place, so 61.6. So now we know that this is 61.6 degrees, and we were asked to find the total bearing, which was from there to there, because bearings are from north clockwise, remember that, and they are in 3 digits. So that leaves us with just adding 61.6 to the 37 degrees, which gives us 98.6 degrees. And as a bearing, it would be 099. We have to round up appropriately and give it in 3 digits. And that brings us to the end of the paper. If you like the video, please give it a thumbs up. Please continue to show your support by subscribing and making sure that you have your notifications on. And I should see you in the next video. Goodbye for now.